Okay, it has started a recording. Normally it announces it audibly, but I guess they've turned that off in this version of Zoom. Okay. Um, so I'm going to summarize the basic background required for what we can do here, but let me start by just pointing out the website, which is all important. Uh, everything, I'm waiting for my browser to launch. There we go. Okay. So everything you need is here at my website, samsclass.info. I'm going to put it in the Zoom chat because what's going to happen here is I'm not going to do a lot of lecturing. I'll do some demonstrations and answer questions, but most of the time you're going to be doing hands-on projects. And as you can see, there will be a scoreboard. This is an old one from a previous class. I'll have a different one for this class. But if you go to samsclass.info, right at the top is the event in progress. Let me refresh this. There we are, which is CyAD conference. And so you click this AI threat management workshop link, and that will get you to this class, all the class materials. And this is structured as a capture the flag contest, which is the standard for security education, because all my classes, including this one, I'm sure, have the same issue that there are people with very different levels of ability and interests in the class. So some people are very advanced and want to rush to particular hard problems. Other people are completely new to it and just want to do the basics, and so on. So rather than having a lecture and a homework with that lecture and everything organized like that, instead there's just a lot of challenges to do, and you can skip the ones that aren't of interest and focus on the ones that interest you most, and I'll explain them and demonstrate them and help people. But it's not at all true that you're all going to learn the same things or in the same order. All I care is that you each find something of use to you. So that's the important thing here. And I'll start you on a hands-on project after I go through a brief lecture. I made a brief version of my presentation from this conference earlier to cover the basic points we're going to talk about here. So that's here. And so I'm an instructor at City College San Francisco and a corporate trainer. And the most important thing is this website, samsclass.info. Oh, and all these materials will be available after the class, and you can use them in your class. That's the whole idea. You can even use my running capture the flag system with the running scoreboard if you want to, and have your students put their scores up there. That's fine with me. All right. So this, I think, is a really good way to think about AI. The Gartner hype cycle is fantastic. And if you haven't seen it, this is extremely useful. There's the period of time when something is new and nobody even knows what it is. Then people start discovering this is a great thing, and there's the region of inflated expectations. And they say, this is it. Everyone's going to lose their jobs. This is going to solve every problem. Then they reach the peak when they begin to realize that the new thing really isn't that great and it has problems and limitations. And then everyone gets too disgusted with it and they flee away from it and hate it. And then when all this nonsense is done, it turns out to just be another thing, like word processing, the internet, the telephone. It's just another technology that has some value, but not as good as you hoped it would be, and not as bad as you feared it would be. It's just another thing. And you may notice the various AI things here, like computer vision, has pretty much been through the whole hype cycle. A few years ago, they were using it everywhere and using facial recognition and stuff to put people in jail. And then they found out that didn't work and everybody got too mad. Now we're kind of getting used to it. Over here at the very peak, you got generative AI, which is the one that's getting all the buzz, which is the large language models like ChatGPT. And people have discovered over the last couple of years that it can really write pages of text that look like a human wrote it. And that caused a bunch of middle management and upper government, it caused middle management people to say, I can fire all my staff because ChatGPT is as smart as my staff, which is completely not true. And it caused a bunch of national government people to say it's going to get smarter than humans and turn into the Terminator and destroy the world. And none of that is remotely true either. So that's why I think Gartner is quite correct to put it at the peak. We've reached the peak of of people expecting it to do crazy things, and people are beginning to realize it's not going to do that much, all those crazy things. And so it's going to fall down here and come down. And so anyway, it's good to see the various options here. All right. So let's talk about types of machine learning systems. And the point here is, in order to correctly understand what this stuff is good for, you have to understand how it works. And it is extremely clear that most of the people screaming about the risks of AI do not understand how it works. It is all just curve fitting, as you're going to see. All large language models do is they draw a curve through some data points, and those data points are English words that have been converted to vectors in a high dimensional space. The miracle is the paper from 2017 that Google put out called Attention is All You Need that figured out how to make a representation of words as numbers that works. And now you just draw a curve through the numbers. But it's not like AIs understand what they're saying or know truth from fiction or know whether anything they're saying is right. They just are fitting a curve through some points and extrapolating it. And if you understand that, then you can see why it gives the appearance of having human intelligence without, in fact, having any intelligence at all in that regard. AIs do not understand what they're saying. They don't even know that there's a world out there. They don't even know that the words mean anything. They're just fitting a curve through some numbers and extrapolating from some words to choose other words that fit. All right, so supervised learning is the easiest to understand. You have an AI system that wants to learn something like to tell spam email from good email, and you have training data with labels. You have labeled some good and some bad. Humans have done the labeling, and now AI just figures out how to reproduce the classification that was done by humans. However, there's a lot of data that's unsupervised. All the pictures on the internet, just if you put up a camera and take pictures of the world as you drive around in your Tesla, you're getting unsupervised information, data that is not labeled by a human. So what can you do? Well, you can categorize it anyway. You can sort it into categories. There appear to be a cluster over here and a cluster up here and such. That's one thing you can do. Another thing you can do is you can decide if one instance is anomalous. There's a region you call normal, and ones that are outside that region are unusual, exceptional. And this might be useful to pick up the bad network traffic from the good network traffic or the defective products on an assembly line. And the other thing you can do is you can take unsupervised data and turn it into supervised data. And this is an extremely powerful technique. You have a photograph of a cat, then you cover part of it with a black box, and now you train your AI to fill in the missing pieces, and you know what the right answer is. So you can train it to get closer to the right answer. And this is how you get the thing I see advertisements on Android phones. They have a feature where you can take a picture and just remove extraneous objects, and it'll fill in the background for you. This is how it works. This is how Stable Diffusion works. And this is how large language models work. This is what Google figured out in 2017. If you have a huge body of written text, like you scrape the internet and get billions of pages of English writing, that is all you need to train to make a mathematical representation of English. So what you do is you take sentences and you mask 15% of the words. So you take this sentence, artificial intelligence, mask, take over the world. You cover one of the words, and now since you masked it, you know what the right word is. And now you have your model try to guess what this word will be from the words around it. And they can practice. One simple way to understand this, although it's more complicated than that, is just looks and says, well, what's the most common word? If I find how many examples of this sentence and how many times is this word can and how many times is this word will, and you get a percentage here. It's more sophisticated than that. It can take a sentence that doesn't exactly match anything in the database at all, but it has learned the trend. So now it can decide there's 30% chance that the word is can and 18% chance the word is will. And in a small change, you got less likely finishes like intelligent says, take over the world, and so on. And so this is enough to train your model to understand how words relate to other words. That's why they say attention is all you need. And the second part of this is you take sentences of data and you replace the sentence after it half the time with the wrong sentence. And half the time it's the right sentence. And again, you know which one is right, and you train it. So from this technique, it learns when writing text in your large language model, it will choose words that go together because it's learned how to choose words that are appropriate in the context of the words around it, and how to use sentences that belong together in the sense that the sentences will read naturally, and that's all it's doing. But the result is you have a mathematical representation of words that gives words that have similar meaning near each other and even makes a mathematical difference between words meaningful. So if you take the word for man and take the word for woman and draw a vector between them, and then you go to king and move that distance, you will get to queen. So it is a logical mathematical organization of words gathered by meaning, and even with meaningful distances for relative meaning, which is what you need. And now when you draw, so your prompt is a series of words, it turns into a bunch of vectors, and you can fit a curve through those vectors and predict what would happen next. So you can feed it a question, and it can give you an answer that will sort of obey the grammatical rules to look like an answer that a human would have given, which is why it has such spectacular errors. If you ask ChatGPT to write Python code, it will cheerfully give you, it will say, here's how we solve the problem. You take this Python code, and then you run it and get this answer. And it will give you the right answer, but when you run that code, it will not be right because it doesn't run the code. It doesn't know it is Python code. It's just making a page that looks like a page you'd find in a manual describing a software product. That's what it's doing. It's making it look like the product, but it's not really understanding what the point is or how to test it. All right, so AI systems therefore have their own special types of risks. The US government has written a risk management framework, but they operate at a very high level, far beyond where most of us have to worry about. They're thinking about destroying society, civil liberties, ending democracy, and things like that, which is a risk, but it's not the risk that most of us are thinking about at the level of, working for a company and helping them develop an AI-assisted product, which is what I'm doing. I consult for companies like that. So this may be useful for the federal government, but this is way above my pay grade and above the pay grade of the companies I work with. This, however, is a document that's extremely useful. This helps you organize the type of AIs that are out there. All right. And so here's the one very useful thing to understand is how difficult it is to understand how AI works. Now, linear regression is where you just take some points and draw a straight line through them, and that's easy to understand. You understand the math involved. It's very simple. Decision trees are almost as simple. They're just AIs that work with a series of if-then statements. If this parameter is above this value, the condition is true, otherwise it's false. It just has a series of if statements, and therefore it's easy to understand how it works, and it's easy to fix it if you don't like what it's doing. For example, if you have an AI system and there's certain behavior that you don't want it doing, like a large language model, you don't want it telling people how to make poisons or bombs. So if you have a simple model like this, then you could easily adjust those statements to avoid undesirable behavior because it's still very close to the normal kind of computer programs human would write. K-nearest neighbors we're going to do in the project. This is a very useful classification system that finds groups in data with a very simple operation, and that's nice. Random forests improve on these simple ones like decision trees by having a lot of decision trees, like 500 of them, randomly varying, and then averaging the output to make the result more reliable. Support vector machines draw the best line to separate two categories in a classification task, and we'll also do that in the projects. But the large language models are using deep neural networks, and those are the most powerful systems, but they're also the least understandable. So if you write a neural net that does this with many layers of neurons imitating in a cartoonishly simple way the human brain, and now you train it to do something like ChatGPT where you can ask it questions and it answers, then if you decide you want to modify its behavior, like I don't want it to tell people how to make a bomb, you don't know which neurons you would change, which weights you would change to enforce that behavior. That's the problem. It's sort of like having a child. They have their own way of doing things, and you can give them orders, but they don't really obey your orders very well. And it's not obvious how to actually make them obey orders, which is going to be a problem we'll do very soon in the hands-on projects. It turns out to be a fundamental problem with large language models that you cannot trust them to obey your security boundaries, and there are easy ways to jailbreak them and get them to violate the security policy. So the UK has written a document to help you see the risks of machine learning, and this one I found much more helpful. When you're planning some kind of machine learning project. You define your objectives and your risk assessments and compliance issues and such. Then you define requirements and develop it. And then you verify and validate the components you're putting in. And then you deploy it. And when you deploy it, you're going to have to monitor to see how well it's working, what problems are there, have logs and some way to handle complaints from users and all that. And then you'll have continually, when you're using it, it'll be constantly learning and improving. That's usually why you do it. You don't want one static system. You want to keep feeding in new data and having it learn new tricks. And then eventually you get to the end of life and you have the usual issue of data disposal and model disposal and a postmortem. What did we learn from this? How will we make the next project better? This sort of thing. This is a much more reasonable way to organize your planning, much more appropriate for companies than the US government one, which is pretty much just at the level of national government as far as I can tell. And OWASP, the Web Application Security Project, has made 2 lists of top 10 vulnerabilities, which are quite useful. Here's the general machine learning risks, and we'll talk about these considerably as we go ahead. The main ones, I would say here, good, telling me to admit people who show up, which is good. Poisoning, evasion and poisoning are the 2 main threats. And input manipulation, I think that's poisoning, that's evasion. If you have a machine learning model that learns things, like, for example, a Tesla car has a camera and it has learned to identify common objects like a stopped car, a pedestrian, and so on. But when you give it something it doesn't know about, like a homeless person pushing a shopping cart down the road, it doesn't know what to make of it. It hasn't been trained on that, so it has input that confuses it. And you could therefore, it says, is that a dog? Is that a car? Is that a tree? What is that thing? And that's the issue of input manipulation. When you give a machine learning model something it doesn't expect and cannot properly interpret. And when I went to DEF CON and other security conferences a few years ago, they would hand out hats and T-shirts that had shiny spots on them saying, this will fool facial recognition system to have a bright spot on your hat. It's the same kind of thing. Data poisoning is where you poison the training data so the model learns bad habits. And this happened to a lot of large learning models like Microsoft. About several years ago, Microsoft put a chatbot on Twitter and it learned from the tweets it saw. So within a day, it learned to say horrible, racist, sexist, offensive things because it learned bad habits from bad data. And that's data poisoning. And these other ones we'll deal with a little bit later. And let me find here we are. All right. So there are details here, but I'm not going to worry about them now. We'll do them in the projects, the important ones. But OWASP also has a top 10 list just for large learning models. And these are quite interesting. Prompt injection is the one we're about to do in the hands-on project, where you give it tricky questions that fool the model into violating the security policy. Insecure output handling is if the output might contain malicious things like code or tags. You might want to be careful passing it on to the next stage. I mentioned already, poisoning the training data will, of course, teach the model bad habits. And there's another one people talk a lot about is sensitive information disclosure. Now that we know that you can train a model on unlabeled data, like the queries that people type in, this is certainly the case. ChatGPT and Google Gemini and the other large learning models online say, if you use the free version, we are going to train our model on your questions because that's a useful data of input. Now, that's why all the large companies have forbidden their companies from using it. I just had to upgrade the company management software on my phone because I'm using it as the second factor for some corporate clients. And it forced me to take the ChatGPT app off my phone. Corporate policy says you cannot have that on your phone. And nobody thinks you're allowed, all the large companies will not let you use it because they will learn from the questions you type in, and they might repeat that in response to a question from somebody else. And people were doing things like taking confidential company data, copying and pasting it into ChatGPT and said, write a summary, prepare a PowerPoint from this. And it can do that, but you're taking a risk of exposing that data to other people. And then excessive agency is a big risk. where you trust these large learning models to do any of these machine learning models to do things beyond what they can really do. This is especially a problem with, as I mentioned, machine learning with large language models, because they write English and appear to be as intelligent as a human and fool a lot of users into thinking they are as intelligent as a human when they aren't. And so you trust them to do something which they really are not qualified to do. And all right. And that's closely related to over-reliance, where people trust the answers when they should know, when they should realize that the model will lie to you. Unfortunately, as we're going to see, large learning models will lie to you very convincingly. It will look good even when it's completely wrong. And that's a problem. So Copilot is probably the most important AI out there, although there are something like 100 different products. Microsoft calls them all Copilot. But the one I'm interested in here is Microsoft 365 Copilot. And what this does is it has access to all your cloud data stored in OneDrive and your spreadsheets and so on. And it will now, you can ask it to write a document, like summarize the current status of this project. It will look through all your emails, all your spreadsheets, all your PDFs and everything to figure out what it should say, and therefore help you write this stuff up. And here's how it works. This is technically called retrieval augmented generation, which is the new hot technique for machine learning models. You have a large language model out here, like ChatGPT, that has been trained on a vast amount of random data, and it has learned the structure of language, mainly the structure of English. So it knows how to write English pages that look pretty good, but it doesn't know anything about your particular internal company data. Then you have this thing called Microsoft Graph, which when you give it a prompt, it will now look through all this company data, your PowerPoints, your health spreadsheets, your emails, and so on. It will find all the data that appears to be relevant to that task, and it will then add it to the query, which is retrieval augmented generation. You're going to build your own models. You'll see how this works in the project. And now it can ask this large language model, include this context in the prompt, and now answer the question. So you use both your knowledge from prior training of how language works in general and the specific knowledge here of what's going on at this company, and you can then write a document that will be trained on our data. And you're relying on Microsoft to obey their promise, which says if you pay your monthly fee and have a paid account, we promise we will not train our model on the data you send up here. So even though your data is sent to a cloud, it is not kept or retained in that cloud in a way that it can leak out again. This is what most people want, exactly this product. And all right, so Microsoft handles certain security issues, but the thing they can't handle is permissions. If some of your data is confidential, yes, I see the question. Yeah, a copy of the recording will be available to everybody. I'll show you where they are when I'm done with this. They'll be publicly available to everyone. All right, and so the problem is, if your data is all labeled, then you can say, I want you to prepare a document, but this is a public document to include only public information. In principle, Microsoft software can do that, but in practice, it doesn't work. And the reason it doesn't work is because there's a huge amount of technical debt, and most cloud data is not correctly labeled by sensitivity. So here's a infographic about it. There are 40,000 permissions in multi-cloud environments. Only 1% of those permissions are ever used, and more than 50% of identities are super administrators. So the current state of cloud data is stored in a very sloppy way without proper security labels or controls on it, and Microsoft Copilot cannot fix that for you. So, and they say the average Microsoft 365 tenant has 40 million unique permissions, thousands of sharing links. It's ridiculous. So it's not like a nice, simple system. And the reason that it happens is because they're automatically generated systems and things you've inherited and so on. The current state of deciding whether who's allowed to reach these resources is just very disorganized. Microsoft has a thing called Microsoft Purview, which will read sensitivity labels on all the data and then apply them to the output. But it will only work if you had, in fact, applied and updated all the labels on your data, and most companies have not. So it is a form of technical debt that is holding back machine learning security. So the tools I found extremely useful for instructors, Perplexity is a big one. Perplexity is, from what I understand, a retrieval augmented generation system. The thing about this is it's like ChatGPT, but it has data, it has access to the current data on the internet. And what it's doing from the angry articles I've read is it's scraping the data just like Google and getting modern web pages and putting them in a database, some kind of summary, and then it's adding that data to a large language model that was trained only up to a certain date, like Microsoft Copilot, to give you more modern answers. So if you ask questions, you'll get good answers and you'll get links to the sources so you can verify those answers. And in practice, it's pretty good. Consensus is one specifically for scientific research. So instead of just using data from all over the internet, it is trained specifically from peer-reviewed scientific journals. And it will give you the links to the scientific journals. So if you're a scientific researcher, this one is very helpful. Anything LLM we're going to use in the projects, anything LLM makes it easy for you to make your own local large language model running on your own hardware without using the internet at all. And also letting you add your company data to it. And this is, of course, what most of my clients want. They would rather have everything run on their own server so you don't have to trust any cloud resource. And this is one way to make a prototype of that. Now, to handle the traffic of a real deployment, you'd use something like Amazon Cloud or something. But this is a way to make a prototype system with customized data so you can see how good it is. Olama is a system also that makes it easy to run large language models locally on your own hardware. You do not need powerful hardware to run one of these models. As you probably all know by now, Apple is going to bring out AI, I think in September, which will run large language models on your phone. So your phone can be enough to do a lot of it. And so we're going to do these hands-on projects, and I'm going to start you on that now. I'm just going to make a separate video of that. Let me stop this one. They seem to have hidden the recording. Oh, there we are.